Okay, in today's lesson, we're looking at using our radian measure now and just looking at our trig equations that we already know and solving trig equations. So first is our trig graphs. Sorry, that shouldn't say trig equations, it should say trigonometric graphs. So our first graph is y equals sine x, and we know normally y equals sine x. When we were working in degrees, the period was 360, and the halfway mark is 180, and then we had 90 there and 270 here. So that's in degrees. And so now if we're learning how to draw them in radians mode. So remembering that pi is 180 and that 360 degrees is 2 pi. So here I put 2 pi because that's one complete period. This will be pi. Okay, this is 0, so we've got 0 pi, 2 pi. Halfway between 0 and 1 pi is pi and 2. Remember, pi and 2 is 90 degrees because it's 180 on 2. And here I've got 1 pi and 2 pi, so this is 1.5 pi or 3 pi on 2. Because remembering that 3 on 2 is 1.5. Okay, again with the cosine curve or the cos curve, remembering that normally goes like that for a period, and we've got 360 there, 180, 90 and 270 again. So the complete period is 2 pi, halfway mark is pi, and halfway between 0 and pi is pi and 2 because that's 180. This is 180 on 2, which is pi and 2. And halfway between pi and 2 pi is 1.5 pi, which is 3 on 2 pi. And the tan curve, okay, we have 0. Remember, it has a period of 180 degrees. So we've got 0. We've got our first asymptote at 90 degrees, which is 180 on 2 or pi on 2. Then this is at pi. This other asymptote here, we've got 2 pi. So halfway between pi and 2 pi is 3 pi and 2. So here we have asymptotes at pi and 2 and 3 pi and 2. So remembering our original curve, the way we drew it, we had it like this. Okay, that was our tan curve. And here we had 180, that was 90 degrees, 0, 270 and 360. Okay. All right, now the cosec curve, just underlining the third letter there, which is S. Remember that the cosec curve bounces off the cos curve. So, and remembering that, so for example, cosec is 1 over sine x. So where sine of x is 0, that's where we have an asymptote now. So I'm looking at the points where sine x is 0. We now have asymptotes at these points. Now, I've drawn more than one period here. Okay, see, I've got one period of the sine curve, so that's 2 pi or 360 degrees. Okay, I'm just going to zoom in there. And another period, so I've got 2 pi, it's 360 degrees, and another 2 pi, so that's 4 pi, is 720 degrees. So here I'll have pi, and halfway between 2 pi and 4 pi is 3 pi. Now remembering this is where sine x is 0, but 1 over 0 is now undefined. So I've got my asymptotes, and at this point here at pi on 2, 1 divided by 1, because sine of 90 or sine of pi on 2 is 1, so 1 divided by 1 is 1. So that's where we bounce off, remembering that we bounce off. And 1 divided by -1, remembering to put in your values here of 1 and -1. Okay, and again we're bouncing off. So that's our cosec curve with our asymptotes. And notice that's one period of the sine curve, another period. Okay, again, the sec curve, third letter is C. So it's the reciprocal of the cos curve. I've drawn the cos curve here, that would be 2 pi, and another period would be 4 pi. And wherever the cos curve's in blue, and wherever the cos curve is 0, that's where we have asymptotes for our sec curve. And wherever, remember this is 1 and this is -1. So we've got, wait, I'll just put the other values in. So I've got 2 pi there up to here. So this here is pi. And 2 pi to 4 pi halfway is 3 pi. Okay, now, so I've got 0, pi, 2 pi, 3 pi, 4 pi. Obviously the ones in between the asymptotes are at pi on 2. Then I've got pi, and halfway between pi and 2 pi is 1.5 pi or 3 pi on 2, etc. Okay, halfway between 2 pi and 3 pi is 2.5 or 5 pi on 2. And halfway between 3 pi and 4 pi is 3.5 pi or 7 pi on 2. Now, wherever it was 0, we've now got asymptotes and we're bouncing off the cos curve. So the sec curve is in red. The original cos curve is in blue. Okay? And here again, you've got pi and 2 pi, that's 2 pi, so this is 1.5 pi, or 3 pi on 2, and so on. 2 pi and 3 pi, so this is 2.5 pi, or 5 pi on 2, and this point here is 3.5 pi, or 7 pi on 2. Okay? And the last graph is the cot curve, which is the reciprocal of the tan curve. I'm just going to do a little sketch here of the tan curve. Remembering that's what it looks like. So we just did that. And here I've got 180 degrees or pi, and here I've got 0. That'll be pi on 2. Now remember where it was, where the tan, so this is y equals tan x. And where the tan curve, so that's the tan curve. And where the tan curve is 0 is where your cot curve, 1 divided by 0, it's where your cot curve is undefined. Now the tan curve is 0 at 0, pi, and here 2 pi. So at 0 and pi, that's where I have undefined values. And where we had undefined in the tan curve, so remember 1 divided by undefined is 0, so you'll now have 0 as your value for your cot curve at pi and 2. And your tan curve was undefined at 3 pi and 2, so 1 divided by undefined is 0. So at 3 pi and 2, we've got 0 on our cot curve. Okay? Now, remember the tan curve goes this way, so your cot curve is going to go, so we've got undefined here at 0. Our cot curve is going to go the other way. Okay? And that's your cot curve, okay? So you've got asymptotes at 0, pi, 2 pi. Now just solving some trig equations in radians. So, for example, if you're asked to solve the following over the domain from 0 to 2 pi, so you're being asked from 0 to 360 degrees, however, you must give your answer in radians. So if they say solve for 0 to 360 degrees, you give your answer in degrees. But if they say solve over the domain, 0 is less than or equal to x is less than or equal to 2 pi, you're being asked to give your answers in radians. So remember, whenever you're asked to solve sine of x is 0, 1 or -1, we always sketch the curve. And the sine curve looks like this. And instead of writing 360 here, we write 2 pi. And instead of writing 180 degrees there, we write pi. So where is sine of x equal to 0? We can just read it off our graph. The solution to that, between 0 and 2 pi, we have a solution at 0, we have a solution at pi, and we have a solution at 2 pi. Now looking at this next question, solve sine of x plus 1 is 0. We'll just rearrange that to be sine of x equals -1. We can just use that same curve. I'm just putting in our amplitudes there. Where is sine of x -1? Well, it's down here. And the value is between pi and 2 pi, between 1 pi and 2 pi, which is 1.5 pi. So x is 1.5 pi, which is 3 pi on 2. So that is the solution to sine x equals -1. Okay, and again, you could be asked to solve cos curves. So if I'm asked the cos curve, just sketching that cos curve, but you must, instead of writing, remember it's 360 degrees or 2 pi radians for the period, for one period, so that would be pi. And here we'd have pi on 2. We've got pi and 2 pi, that's 1 pi, 2 pi, halfway is 3 pi and 2. So where does cos of x equal 0? Where you sketch the curve and you can see it equals 0 for the values of pi on 2 and 3 pi on 2. Now this one here, cot of x equals 0, again you would just do a quick sketch. Remember tan goes this way. We've just drawn the cot curve, so if you can remember what it looks like this, goes the other way. And these values, so I've got pi here and I've got 2 pi there. So this will be pi on 2 and this is 3 pi on 2 or 1.5 pi. So where does cot x equal 0? Your solutions from 0 to 2 pi are pi on 2 and 3 pi on 2. Okay, now other things that we can do are, again, solve these equations. Now we've solved these a few lessons ago, but now we're being asked to solve, giving our answers in radians. So it may say solve for 0 less than or equal to x less than or equal to 2 pi. So we just use the same method, and just when you're reporting your results in part 3 and your step 2 where you're saying what the acute angle is, you need to be in radians. So step 1, remember, is the quadrants. So we say that sine of x is negative in this case, is negative in, well, which quadrants is sine of x negative in? It's negative in quadrants 3 and 4 because all stations to central. Step 2 is always your acute angle. So my acute angle x. Now sine of what is root 3 on 2? Is it sine 30, sine 45 or sine 60? Now we know it's sine 60. So sine of 60 is root 3 on 2, and you say to yourself, what's 60 degrees? It's 180 over 3. So I'm just going to put that it's 60, but we're not meant to be putting that. But 60 degrees is pi on 3. So you will write acute angle x equals, probably I should put that there. You'll put equals pi on 3, and I'm just going to put in brackets here that it's actually 60 degrees. That's how you know, 180 over 3. So acute angle x is pi on 3. So now we're going to do a little sketch, and instead of putting 60 in, so we know it's quadrants 3 and 4, instead of putting 60 here and here, we write pi on 3, pi on 3. So now we have to write our solutions. So step 3. Remember, we've got 0. This is pi on 2, and this is pi, because this is 90 degrees and 180. So here are my two solutions. And then we keep going. That's 3 pi on 2. And this is 2 pi. So I've got 0, pi on 2, pi, 3 pi on 2, and 2 pi. So I want to write down my solutions. So my first one is there. So it's pi plus pi on 3. So my first solution is pi plus pi on 3. And in quadrant 4, I'm going all the way round to 2 pi, but I'm short pi on 3. So this is really like 180 plus 60. Okay, and this other one is really like 360 minus 60, but we have to write it in radian measure. So instead of writing 360 minus, I write 2 pi minus pi on 3. Okay, now I can't just leave it like that. I have to write my solutions. So this is 1 pi plus a third pi. That's 1 and a third pi, which is 4 pi on 3. And this is 2 minus a third. Now 2 minus a third is 1 2/3, or 5 pi on 3. Okay, now we did a little bit of that last lesson. Okay? Okay, now the next question, solve for. So we're solving for 0 less than or equal to x less than or equal to 2 pi again. Okay, now cos of x is 1 on root 2. So again, our 3 steps. Cos of x is positive in quadrants. We've got all stations to central, quadrants 1 and 4. Step 2, same thing. The acute angle x So cos of what is 1 on root 2? So is it cos 30, cos 45, or cos 60? Well, it's cos 45 degrees. I'm just going to put that over here. And I know that 45 degrees is pi on 4 because it's 180 divided by 4. So that's my acute angle. And step 3, my solutions. Now I have to sketch it again, remember, quadrant 1 and quadrant 4. And I've got pi on 4 in there instead of 45. And so I just go around, and my first angle is in quadrant 1, so it's pi on 4. And my last, remember, I've got 0, pi on 2, pi, because that's 0, 90, 180. 270 is 3 pi on 2. And coming back to 360, that's 2 pi. So I've got pi on 4, and then I've got to go all the way round to this one. So quadrant 4 is 2 pi, 360. It's really 360 minus 45. So it's 360. So it's 2 pi minus pi on 4. So if I made it all the way around, it would be 2 pi, but I'm short pi on 4. So my solutions are pi on 4 and 2 minus a quarter is 1 3/4 or 7 pi on 4. Okay, so it's 1 3/4 pi, which is 7 pi on 4. Okay, now just another 2 here. Solve this for, we'll just keep going, 0 to 2 pi. Okay, so we rearrange it because we can't solve it that way. So I've got tan x is negative 1 on root 3. So, okay, again, the 3 steps. So tan of x is negative in quadrants. We've got all stations to central. So it's negative in quadrants 2 and 4. And then we need our acute angle, x. So we say tan of what? Tan, remember the negative just tells you the quadrants, or if it's positive. Then we say tan of what is 1 on root 3? Is it tan 30, 45, or tan 60? Well, it's tan 30. Now, what is 30 degrees? 30 is pi, is 180 on 6, so it's pi on 6. And now we just have to draw in our solutions. So we're looking in quadrants 2 and 4. And our angle is pi on 6. So finding our solutions, we've got quadrant 2. So quadrant 2 would be 180, but short that amount. So it's, remember, 180 is pi. I've got 0 and pi. And then down here I've got around 1 full revolution, I've got 2 pi. So this is, like, it's like 180 minus. So that will be, so step 3, my solutions are 180 minus, which is pi minus pi on 6. And quadrant 4 is 2 pi minus pi on 6. So my solutions are 1 minus 1/6, that's 5/6 pi. And my other solution is, sorry, that's not 2 pi on 6, that's just 2 pi minus pi on 6. Sorry, just a little type error. And this is 2 minus 1/6 is 1 5/6, which is 11 pi on 6. Okay, the other way you can think of it is that 2 pi is 12 pi on 6, because 12 over 6 is 2, and we're working in 6. So your 12 pi on 6 minus 1 pi on 6 is 11 pi on 6. You can think of it like that. And you can think of this pi as 6 pi on 6. Okay, so 6 pi on 6 minus 1 pi on 6 is 5 pi on 6. Or just 1 minus 1/6, 2 minus 1/6. Okay, now the last one's a little bit different. So I've got sec of x plus 2 equals 0. Now I have to rearrange it. So I've got sec of x equals negative 2, and we're going to divide by the root 3. Okay, now remember sec is the reciprocal of cos, so therefore cos of x would be the just the reciprocal, because sec is 1 on cos, so that would be negative root 3 on 2. It's still going to be negative, okay, but you just have to do the reciprocal, and in the case of a fraction you will just flip it. So we're just solving this. Cos of x equals negative root 3 on 2. So just the same steps again. Cos is negative in which quadrants? 2 and 3. Okay, our acute angle. So our acute angle x. So cos of what is root 3 on 2? Is it cos 30 or cos 45 or cos 60? Well, it's cos 30. So 30 is 180 on 6. Okay, so you just think to yourself, well, that's 30. Okay, and our little sketch in quadrants 2 and 3, instead of putting 30, we put pi on 6 and pi on 6 in there. So that was step 2. So step 3, my solutions are, remember I'm starting from 0, pi on 2 and pi, and all the way around to 2 pi. So 0, 90, 180, 270 is 3 pi on 2, and 2 pi again is 360. So here are my solutions. Those two. So I'm short. I'm not quite pi, so I'm pi minus pi on 6. And the second one will be 180 plus, or pi plus pi on 6. So that's 1 minus 1/6 is 5/6, so it's 5 pi on 6. And 1 plus 1/6 is 1 and 1/6, which is 7 pi on 6. So they're my solutions. X is 5 pi on 6 or 7 pi on 6.